And some days, the air feels heavier. Every year, emissions keeps rising. Cities grow, and with them, the invisible threats grow too. We wear masks, shut our windows, but it's never really enough.
Increasing graph of CO and CO2 emission may lead to something serious. So, what should I do? What's the solution of this problem?
One of the solutions is a special kind of filter, an absorbent membrane. Unlike conventional air filters that only trap dust particles, this membrane is designed to absorb harmful emission gases, especially carbon monoxide and carbon dioxide. However, the commercial product of it is usually made from synthetic polymers that take decades to decompose. In contrast, semi-synthetic polymers like cellulose acetate will decompose within months, making them more eco-friendly. Coconut grass or Imperator cylindrica, a plant that is rich in alpha-cellulose, is an ideal cellulose acetate source. It is also one of 100 of the most invasive plant species in the world, ensuring abundant availability. By incorporating cellulose acetate from coconut grass with non-activated carbon in mixed matrix membrane, the effectiveness of absorption of gases will increase. The utilization of a composite of thick wood mixed with T-Rex waste with this content as nano-activated carbon synthesis material can be applied to MMM.
And that is why the researcher would like to present to you the study of synthesis and absorption test of mixed matrix membrane filter based on cellulose acetate from coconut grass with non-activated carbon composite from T-Rex waste and thick wood powder as an air pollutant absorbent.
And these are the problem formulation and the research objectives.
So, the research is divided into 4 steps. First one is the preparation of cellulose acetate, the preparation of non-activated carbon, mixed matrix membrane synthesis, and the last one, the absorption test. First, clean, soak, dry, and process coconut grass into fine fibers. And the next one is to treat it with chemical solutions to extract and purify cellulose. Acetylate the cellulose to obtain cellulose acetate, and then heat, carbonize, and activate tea sawdust and tea trees. Chemically treat and filter to obtain purified non-activated carbon. Mix cellulose acetate and non-activated carbon in various ratios, including 4:0 and 4:3, with a solvent. The next one is to stir, silicate, and cast into thin films. And the last one, the absorption capability of the synthesized MMM for CO and CO2 emission gases was tested using a CO meter. And then, the quantitative data obtained from the CO meter was calculated using this equation. The researcher conducted FTIR test on cellulose acetate produced from coconut grass. The FTIR result showed the presence of carbonyl groups, which proved that the acetylation process was successful. Next, FTIR were conducted on non-activated carbon composite made from T-Rex and thick wood powder. The results showed that the sample with a 3:1 ratio of T-Rex and thick wood powder gave the best performance. The researcher also tested the absorption ability of MMM with cellulose acetate and non-activated carbon ratio of 4:0 and 4:3. The MB sample showed the best performance, with a CO2 absorption percentage of 65.52% and CO of 75.80%. Although the MB sample was not better in CO2 and CO absorption, the MA sample showed a higher mass increase, indicating that the MB sample might also absorb other gases besides CO2 and CO. So, from this study, it can be concluded that the synthesis process of MMM from coconut grass, cellulose acetate, and non-activated carbon composite of T-Rex and thick wood is cellulose extraction, acetylation, non-activated carbon composite synthesis, and MMM synthesis. Sample MB with a ratio of 4:3 showed the best results in terms of CO2 and CO absorption, with a CO absorption percentage of 65.52% and CO of 75.80%. For future research, it is recommended to test a more diverse ratio between cellulose acetate and non-activated carbon, and use other base material that have high cellulose content. and test the absorption of other gases to strengthen the results of this study.